Here are endomorphisms of cyclic groups plotted in Desmos. The top numbers are the pre-image, and the bottom numbers are the image of the endomorphism. So endomorphisms are homomorphisms from a mathematical object to itself. Homomorphisms are operation-preserving functions, meaning that if I have a true mathematical statement in the pre-image, it will become a true mathematical statement in the image. And I can demonstrate this for, I drop the modulus down to 6 and then drop this down to 0. If I have 1 plus 3 is congruent to 4 modulo 6, that could become 0 plus 0 is congruent to 0 modulo 6. Or it could become, in the case of this identity endomorphism, it could become 1 plus 3 is congruent to 4 modulo 6, pretty boring, but we could also get 1 plus 3 is congruent to 4 modulo 6, becoming 2 plus 0 is congruent to 2 modulo 6. Or 3 plus 3 is congruent to 0 modulo 6. Or 4 plus 0 is congruent to 4 modulo 6. Or 5 plus 3 is congruent to 2 modulo 6. Now, something that is interesting or of note is that the elements that are sent to the identity, in this case for addition, the identity element is 0. The elements that get sent to the identity element are called the kernel of the endomorphism. So here, the kernel includes 0 and 3. And the kernel is always a normal subgroup of whatever the group is. So if I increase the modulus to 7, the only normal subgroups that we get are either the entire group, 0 through 6, or just the identity element. So we either get a trivial endomorphism that just sends everything to 0, or we get what are called automorphisms, which are invertible endomorphisms. So here the kernel is just the identity element, and so it's possible to work backwards to what you started out with. But here, if I am in mod 6, and say in the pre-image I had 0 plus 3, in the image that just becomes 0 plus 0. I don't have any way to work back because it's not a one-to-one relation. Anyway, these various endomorphisms look cool, so I'm just going to let these play for a little bit. Maybe I can increase the speed a little bit. Anyway, let's pause this now, and here I will show what the equations look like